Assalamu alaikum wa rahmatullahi wa barakatuh. My dear students, you are welcome to the 11th edition of our online mathematics class. This morning, we want to look at conditional permutation. Conditional permutation. That means it is possible that you are given a problem to solve that involves permutation such that some conditions are given or there are some restrictions. Example is what we have on the board. Example is what we have on the board. Now, if you read that example carefully, we are told that in how many ways can the letter of the word school be arranged? If the two zeros must not come together, then B, if the two zeros must come together. So, solution to this. Of course, we have the word school. School. So if these two zeros must not come together, then that means we can restrict this. Ordinarily, if you want to permutate this should be 1, 2, 3, 4, 5, 6. That should be 6 factorial divided by 2 because divided by 2 factorial because 0 appears twice. But in this case, if you have restricted this, what you are left with is SCHL, which is 4. That means that our solution is equal to, we can have 4 factorial, then multiply by, divided by, if those two zeros, of course, it is 2 factorial. So the other is that we could have 5 and and 4. Because you have restricted, the 1 0 could be placed in any of these. 1 0 could be placed in any of these, and if that is the case, we have another 5. Or the other 0 could also be placed. If 1 0 is placed here, the other 0 could be placed here because they are not going to be on the same side, and that is what we are going to have. And in that sense, we are going to have this to be equal to, of course, these 2 factorial, we have 4 factorial multiplied by what? 5 multiplied by 4 all over 2 times 1. Of course, this 2 and this one we have 2. And of course, 4 factorial is what? 24. Because 4 factorial is 4. 4 times 3 times 2 times 1 times 5 times 2. And in that sense, we are going to have what? 240 ways. If you do your calculation very well, you have 240 ways. So if the two zeros must not come together, then we are going to have 240 ways in which we can permutate the word school. The word school. Then the second one is if the two zeros must come together. If the two zeros must come together, of course, that means that instead of having the word school, we have believed that the two zeros can be taken as 1. And in that sense, if you deduct the 2 zeros, you still have 1, 2, 3, 4. That is what? 4 factorial multiplied by, of course, the 2 zeros will become 1 and they can be placed in any of these places, which means you have 5. So multiply by 5. And that will be what? 4 factorial is what? 24, because it's 4 times 3 times 2. Multiplied by what? 5. And in that sense, you are going to have 120 ways. So that's what we are going to have. 120 ways. I hope that is clear. Another example under this that I have is this. I will call it example 2. Example 2. We are told in how many ways can 6 boys and 2 girls be seated at a round table. Solution to this, I have told you in our previous class that whenever you want to arrange in a circular form, whether around a table or whether in a circular conference, the factorial will be what? N minus 1 factorial. The permutation of that will be n minus 1 factorial. So in this case, we are told that in how many ways can 6 boys and 2 girls be seated at the round table? 6 boys and 2 girls, making a total number of 8. That means you have 8 people. And the factorial of what around a round table will be what? 8 minus 1 factorial, which is equal to what? 7 factorial. And of course, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is what? That is 5, 0, 4, 0 ways. So that is what we are going to have. 5, 0, 4, 0 ways. That is the 7 factorial. So that is that about permutation. Now, this one, we want to proceed and look at combination. 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 A combination may be defined as a selection of R different objects from N distinguishable objects in which the order of selection does not matter. In which the order of selection does not matter. What did I mean? Now, combination. A combination may be defined as a selection of R different objects from N distinguishable objects in which the order of selection does not matter. Double T. Now, in this case, we usually denote combination using N combination R. And the definition of this is what? If you like, you can say permutation N permutation R divided by R factorial. If you like, you can say that. That's one way. Or you can still say that N combination R is what? N factorial all over N minus R factorial, half factorial. What am I saying? That you can still say N combination R is equal to N factorial all over N minus R factorial, R factorial. So any one of these two formulas can be used. Example 1. How many combinations are there if 17 is taken, or if 17 are taken? Are there in 17, are there in 17 taking 5 at a time? 17 taking 5 at a time. Solution. That is 7 combination 5. There is no restriction. The objects they are distinguishable. You have 7 things. You want to take 5 at a time. What you need to do is as simple as saying that you have, of course, we know that n combination r is equal to n factorial all over n minus r factorial. So you now have 7, you want to take 5, of course, it's going to be what? 7 factorial all over 7 minus 5 factorial. In this case, your n is 7, your r is 5. Your n is 7 and your r is 5. And that means that you are going to have it to be what? 7 factorial all over 7 minus 5. It is 2 factorial, 5 factorial. And this is what? 7 times 6 times 5 factorial all over 2 factorial, 5 factorial. 5 factorial and 5 factorial will go. 2 factorial is 2 times 1, and of course it's 2. So 2 here, 1, 2 here, 3. You now have 7 times 3. Of course, 7 times 3 is what? 21. So you have 21 ways. You have 21 ways. So that is that. Very clear. Another example, which I will call example 2. Example 2. A bowl contains 7 cooked and 5 uncooked. 7 cooked and 5 uncooked eggs, comma, in how many ways can a 2 cooked or 3 uncooked eggs be selected? How many ways can 3 cooked, than 2 cooked and 3 uncooked be selected? Or 3 uncooked be selected. Then B, 2 cooked and 3 uncooked eggs be selected. Solution. Now, if you look at this very well, I want to read this properly for clarity. We are told that a bowl contains 7 cooked and 5 uncooked eggs. Then in how many ways can A, 2 cooked or 3 uncooked eggs be selected? B, 2 cooked and 3 uncooked eggs be selected. Now, total number of cooked eggs, they are 7. If you want to select 2 cooked from 7, that is 7 combination 2. Number of cooked, if 2 are cooked, that is 7 combination 2. If 3 are uncooked, we have 5 that are uncooked. So if you want to select 3 uncooked from 5, that is 5 combination 3. And don't forget, in mathematics, or simplest means addition. So selection of 2 cooked, to select, I will say to select 2 cooked from 7. We have 7 combination 2, which is 7 factorial all over 7 minus 2 factorial multiplied by what? 2 factorial. and this is equal to what? 7 factorial all over 5 factorial 2 factorial, and this is the same as what? 7 times 6 times 5 factorial all over 2 factorial 5 factorial. 5 factorial and 5 factorial will go 2 here 1, 2 here 3, 3 times 7, that is 21 ways. 21 ways. Also, to select 3 uncooked, I will say to select 3 uncooked from what? 5. We are going to have 5 combination 3. We are going to have 5 combination 3. And what that means, is that 5 combination 3 is going to be 5 factorial all over 5 minus 3 factorial, 3 factorial, and of course which is equal to 5 factorial all over 2 factorial, 3 factorial, and that is what? 5 times 4 times 3 factorial all over 2 factorial, 3 factorial. This and this will go. 2 factorial is 2 times 1, which is 2. 2 here 1, 2 here 2. 2 times 5, 10. So we have 10 ways. So to select, I will now say, to select 2 cooked or 3 uncooked, that will now be 21 plus 10, which is 31. So our answer is going to be 21 plus 10, which is equal to 31. So we can do this in 31 ways. Then the second one that says to select 2 cooked and 3 cooked. To select 2 cooked and 3 cooked. Of course, and in mathematics means what? Multiplication. This is A. So B. To select 2 cooked and 3 uncooked. B. To select 2 cooked and 3 uncooked. We are going to have what? 21 multiplied by, and means multiplication, multiplied by what? 10, which is equal to what? 210 ways. So that's the number of ways of doing that. That's the number of ways of doing that. I hope this is very clear. It's very clear. The last example that I have here, which I will call it example 3. The last example I have which I will call example 3. Last example, which is example 3. In how many ways can a committee of 7 consisting of 4 men and 3 women be formed from 8 men and 5 women. Solution. Look at this very nice question. Let me read it properly so that you can understand. Example 3 says, in how many ways can a committee of seven consisting of 4 men and 3 women be formed from 8 men and 5 women? Now, we want to form a committee that will consist of 4 men and 3 women from a committee that has already consisted of 8 men and 5 women. That means that you want to select 4 from 8 for the men, and you want to select what? You want to select 3 from 5 for the female. You want to select 3 from 5 for the men. So I will say that number of ways of selecting 4 men from what? 8 men. Of course, is 8 combination 4. It's 8 combination 4. And that will be what? That will be what? That will be what? 8 factorial all over 8 minus 4 factorial, 4 factorial. Which is equal to 8 factorial all over 8 minus 4 factorial, 4 factorial. And this is equal to 8 factorial all over 4 factorial, 4 factorial. And this is equal to 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial, 4 factorial. Of course, 4 factorial and 4 factorial will cancel out. And I have this to be what? 8 times 7 times 6 times 5 all over this 4 factorial that I have at the numerator is the same thing as 4 times 3 times 2. So here, of course, 4 here, 1, 4 here, 2, 2 here, 1, 2 here, 1, 3 here, 1, 3 here, what? 2. So I'm going to have 7 times 2 times 5, which is equal to 70 ways. So we can select, the number of ways of selecting 4 men from 8 men is 70 ways. Now, number of ways of selecting 3 women from 5 women is going to be what? 3 combination 5 as usual. 3 combination 5 is equal to, 5 combination 3, sorry, and that is what? 5 factorial all over 5 minus 3 factorial, 3 factorial, and that is equal to 5 factorial all over 2 factorial, 3 factorial, and that is 5 times 4 times 3 factorial all over 2 factorial, 3 factorial. This and this will go. 2 here, 1. Of course, 2 factorial is 2 times 1, and which is 2. 2 here, 1, 2 here, 2. 2 times 5, 10. So we have 10 ways of selecting what? 3 women from 5 women. So the number of selecting 7, that is, the number of selecting ends, I will say ends, number of ways of selecting 4 men from 8 and what? 3 women from 5 is equal to what? 70 multiplied by 10, which is equal to 700 ways. Which is equal to 700 ways. So that is that. That is that. So inshallah, your assignment, I'm going to create it on the school portal for you to see, and make sure you do it. If you're having difficulties, my number has been sent to you on the WhatsApp. You can easily send your question. Inshallah, before 24 hours, I'm going to respond. I will respond to your question, inshallah. So read your book. We are going to meet again on next week. Subhana rabbika rabbil izzati amma yasifun. Assalamu alaikum warahmatullahi wabarakatuh.